Welcome to my lesson. It's lesson 6.2, module 6, section 2. It's all about one-step equations. It is for either of these textbooks here. It doesn't matter which one, it's the same content. And by the way, if you want a copy of the notes that you'll see on this lecture, you can click the link in the description. You can have your own copy of what's going on here. All right, let's get started. So we have an example, and we're asked to solve this equation. We know it's an equation first off because there's an equal sign right there. And when we solve, we're trying to figure out what is the value of x that makes this work. Well, what we do is we use this idea called inverse operations. And the idea of inverse is really just the opposite operation. So if you have addition, the opposite or the inverse of it is subtraction. If you have multiplication, the inverse of that is division, and so on. So I'll erase this whole part here so it gives us a little bit of room. And I'm going to use the idea of inverse operations. Now we're looking at this. We want to know, it's always nice to say, hey, what is the value of x in this case? And what's getting in the way of that is this adding 3.2. So the inverse of that is subtracting 3.2. So I would subtract 3.2, and you have to do it from both sides of the equal sign to keep everything balanced, because equations are like balances. What you do to one side of the equal sign, you have to do the other side. So what happens here is 3.2 minus 3.2 is 0. That part is 0. And x plus 0, where really is just x. So that's great. On the left-hand side, we have x plus 0 is x, fine. But we have to do this part right here now, and they're both the same sign, negative 8.5. This is the same thing as doing this. You have negative 8.5 minus 3.2. Now, in this case, it's pretty easy to see that they're the same sign. You're going to add them up. And when they're different signs, you would subtract them. But they're the same sign, so we're going to add them up, and it's still a negative. And 5 plus 2 is 7, 8 plus 3 is 11, and that is our answer. This is known as the solution. And I'm going to erase this here to make a little bit of room. Let me explain what the solution is. So if I take my original right here, and I place negative 11.7 in for x, this should work now. I have negative 11.7 plus 3.2 should be equal to negative 8.5. And by the way, this is left over from what we were doing earlier. That does not mean it's not equal to, let me erase that part. It's still very much equal to. Okay. Oh, I just erased stuff. Let's see. This has to go here. That's supposed to be my solution. So it's negative 11.7 plus 3.2. Now these are different signs. I would hopefully this is negative 8.5, which it will be, but to test it, these are both different signs. So I'm going to subtract them. So I'll have 11.7 minus 3.2, and that's 5. 8 minus 3, 11 minus 3 is 8. So yeah, when I subtract these, it's going to be negative because there's more negatives than positives, and then 8.5, and that is equal to negative 8.5. So this is known as checking your solution. It works. This is still our answer right there. That's what we'd be expected to put down. Negative 11.7 is the value of x. Let's try a couple more here. We have, let's go on to example 2. And example 2, let's do negative 2/3 plus x equals 8. Okay, so we want to find out what x is equal to. And we're adding a negative 2/3. So if we add a positive 2/3, that would be known as canceling right there, because negative 2/3 plus 2/3, that is 0. Okay, and then I have 0 plus x. But if you add 2/3 on the left-hand side of the equal sign, you have to add 2/3 on the right-hand side of the equal sign. So we'll do that. And 8 plus 2/3 is simply 8 2/3. So there you go. X has to be 8 2/3. That would be our solution. Pretty easy, huh? Okay. Let's go on to our final example, number 3. Negative 30 is equal to negative 0.5 times x. Okay. Now, we have to identify the operation that's happening here. That's negative 0.5 times x. That's multiplication. And we need to use the inverse. The inverse of multiplication is division. So we will divide by negative 0.5, that exact number right there. And you have to do it to both sides of the equal sign, negative 0.5. Now, when you multiply by something and divide by that same thing, it's like you did nothing. I mean, imagine this. Let's say you have 2 times x divided by 2. Well, if you multiply by 2, and you divide by 2, you just forget it. They cancel those actions out, and that's just x. So that's the same thing that's happening here. We are multiplying by negative 0.5, and we're dividing by negative 0.5. Forget about it. Just cancel those things out. We have x is equal to, now we have to take negative 30 divided by negative 0.5. Now a negative divided by a negative is a positive. So we know our answer is going to be positive. And we need to know now 30 divided by 0.5. Now you can think this through. And you can say, well, how many halves fit into 30? And that would be 60. So 60 is equal to x. And I don't have to put positive 60. I could just write 60, right? But let's say you didn't see that and you didn't know. Well, how could you calculate this? Well, what you could do is this. Let me erase my little positive here. It's bugging me. So I'm going to do this 30 divided by 0.5. Cowboys and horses. The cowboy is on top. The horse is on bottom. So the horse sleeps outside and the cowboy sleeps inside. That's how you turn a fraction to maybe a decimal, or to divide it out. All fractions are division problems. So I have this. I got to sweep that over 1. The decimal inside is right here, and I got to move that one over 1. So the decimal belongs here, but I need a 0 right here. Okay, so it's like having 5 into 300. And let me erase some stuff to clean this up. So it's like I'm doing this. 5 into 300. So how many times 5 go into 300? Well, let's see. 5 goes into 3 0 times. 5 goes into 36 times. 5 times 6 is 30. 0, 0, 60. See? That's how you can get 60 right there. Or you can plug it into a calculator. 30 divided by 0.5 is 60 still. So these are just a few of the examples, but the overall idea is this idea of inverse operations, where the inverse of addition is subtraction, the inverse of multiplication is division, and you use those, you identify what is the, like in this one, what is the operation happening? It's multiplication, so we do the inverse and we divide to figure out what x should be. And that's all I got for you here on this lesson. Thanks for watching. See you next time.